May Speakers Night, and welcome to everybody who's watching online as well. I'm the president, Ralph Chu, and it's my pleasure to be your host for the evening. Do we have anybody here for the first time at all tonight? Oh, we've got one couple of people. Welcome. Hey, that's great. This is one of two types of meetings that we have. This is a formal lecture that we're going to be hearing tonight. The other type of meeting we'll talk about later on is a recreational astronomy night meeting, which is a more informal proceeding, and I'll be talking about the scheduled talks for the next of those at the conclusion of this evening. So I hope that you'll enjoy both types of meetings as you come in to join us. So tonight, our lecture meeting, our speaker is Casey Moore, who is a PhD candidate in Earth and Space Sciences at York University. For his master's degree, Casey studied stellar populations in compact elliptical galaxies, and yearning to study something a bit closer to home, Casey switched to planetary science for his PhD and made a 4,000 kilometer move to Toronto. He is a science team member on NASA's Mars Science Laboratory mission. Thus, his current research is predominantly Mars-centric, studying the dust environment local to the rover. His body of work, along with that of his colleagues, and extensive research make him a seasoned Martian meteorologist. Hence, he'll be talking tonight about Martian weather. Is it really any different from weather in Canada? So please welcome Casey.
Thank you. Okay. So as you just heard, that my title is Martian Weather. Is it really any different than winter in Canada? So let me first preface this by saying I am by no means an expert in everything Mars and everything Mars climate, but I hope I can at least tell an interesting story. All right, thank you for the likes. All right, so the very first image that I'm showing here is an image taken from the NASA Viking mission. So NASA sent out two different orbiters and landers to Mars in the mid to late 70s. And this is one of the first global composition maps, global maps of Mars that was received from the Viking 1 mission. So a little brief bio about myself. So it was already kind of mentioned. So I have a BS in physics, and that was when I discovered that I love astronomy. And so I decided to get a master's in physics, but I realized I did not like galactic astronomy. And so I wanted to return closer to home and study Mars. And this is a lovely cake that shows the planets of our solar system. And I'm here at York, or I'm in Toronto at York University studying Earth and Space Sciences, specifically planetary science. Also mentioned is that we are part of the Mars Science Laboratory Participating Scientist Program. So this is mainly through my boss's hard work, who is the young person right here. And this is 4 current members on the team, and we have 1 extra, but she recently came onto our team. So far, I've spent roughly 2 Mars years on Mars, which is close to 4 Earth years. And I primarily study dust in the Martian atmosphere, both with the rover and in the lab at York. All right, so the inspiration for this talk came from a CBC News article. This was my first Canadian winter in Canada. So Winnipeg, deep freeze, as cold as uninhabited planet. So on this specific day on Earth in Manitoba, and at the specific location that they were talking about on Mars, which was where Curiosity is, Mars was -29 Celsius, and Winnipeg was -31. And I'll just preface this, I'm an American, so I didn't want to single out Winnipeg in my title, but it was the inspiration for the talk. All right, so I'm going to assume most of you know the planets, but just for reference, Mars is the 4th planet from the sun. This is not to scale, which I figured out after I already made the talk. It's roughly 50% further from the sun than Earth is. So we're going to talk a little bit about the differences between Earth and Mars, specifically just sizes and stuff. So its mass is roughly 10% of Earth's mass. Its diameter is roughly half of the diameter of Earth. It has a density that's quite significantly lower, and that just means that it's made of different stuff that Earth is. Its gravity is around 40% of Earth. A day on Mars is actually slightly longer, but this is actually interesting because, as mentioned, we work with the Mars Science Laboratory, and we work on Mars time. So a Mars day is 20 hours and 40 minutes or so, or 24 hours and 40 minutes or so. And so every few weeks, we have to adjust our scheduling to make up for that lost time. Its orbital period, so its travel time around the sun, is 687 days. And its obliquity, which is its tilt with relation to the sun, so its polar axis, is pretty close to what Earth's is. So Earth is around 23, and Mars is around 25 degrees. And it's 230 million kilometers away from the sun, and it has 2 natural satellites, Deimos and Phobos. And this is just a graphic showing the moon as viewed from Earth, Deimos, and Phobos as viewed from Mars. So it is possible to image those from the surface of Mars. All right, so I mentioned earlier, its obliquity is similar to Earth. So this means that Mars also experiences seasons. However, the southern winter is a little bit more harsh on Mars than it is in the northern winter. So I used to teach an astronomy course, and the way that we would explain seasons on Earth is ask the students if they thought seasons were produced because every now and then the Earth is closer to the sun, or if it's due to the tilt of the Earth. And so for Earth, that doesn't make a huge difference. So the distance between the Earth and the sun only differs by roughly 3%. And that doesn't make much of a difference to our seasons. And the way that you think about that is saying if there's a huge bonfire 100 meters away from you, and you step 3 meters closer, do you feel any warmer? Probably not. However, with Mars, the distance between its closest approach to the sun and its furthest approach from the sun differs by 17%. So again, the same analogy is saying if you were 100 meters away from the sun or from a bonfire and you stepped 17 meters closer, would you feel a difference? In this case, probably. And so this just happens to happen when the southern hemisphere of Mars is experiencing a winter due to its obliquity. And spoiler, you won't be able to survive on Mars without proper protection. The atmosphere is very thin. I didn't put it on here because I wasn't sure if there would be children here. Your blood would probably boil, your skin would freeze, and you couldn't breathe the air. Yeah, and you want to be able to find liquid water at least on the surface. It would evaporate. All right, so I kind of gave you an idea that you would freeze. So a byproduct of physics is something called the planetary equilibrium temperature. And so this is just assuming all of the sun's energy goes straight onto the planet, and it's a function of the distance from the sun and the planet's albedo and a few other factors. This does neglect the atmosphere. So if you add an atmosphere, it will warm it up. If you calculate this for Mars, you get a bone-chilling minus 60 degrees Celsius as an average temperature. But this method isn't always correct, because if you do it for Earth, you get an average temperature of negative 20 degrees Celsius. And obviously that is not the same. So maybe there's hope. I will let you guys know in a bit. All right, so I broke this down into a bunch of different Mars missions that have been launched. I believe all of them are NASA-based, so I apologize to any ESA or Soviet Union folks. And yeah, we'll just go on. But in the corners, I'm going to put the mission logos so that you know which mission I am discussing. And this one was actually really interesting because I was looking for a nice high-resolution scan of one of these for the Viking landers. But these happened in the 70s, and there was no vectorized computer-friendly version of their logo because they did not need it. So this was actually something that was sewn onto someone's jacket and worn. So Viking 1 and 2, they both arrived at Mars in late 1976. One of them, Viking 1, was in continuous operation until 1982. So it was there for a very long time, and it was one of the longest running missions to date. I think it was recently broken by one of the other missions that we will be discussing. So this is Carl Sagan standing in front of a prototype for the Viking lander. So they sent two exactly identical landers to Mars. And just for comparison's sake, this is around a 600 kilogram item. And when I put that into a weird calculator that tells you weird things, it told me it's about the size of a cow. So, not Carl Sagan, the lander. All right, so they landed in two different spots, which if you have two different landers, you preferably want to put them in different places. So this is where my age may come in. I did not realize the reason why they sent orbiters and landers until doing this project. So before then, there weren't high-resolution maps of Mars. People didn't know where they wanted to go. And so when each of these missions got to Mars, they scoped out the planet for a month and decided where to land. So Viking 1 decided to land here. Viking 2 left here. I do not remember the names of the places, unfortunately. But I do know that Viking 2 is roughly at the same latitude that Victoria, British Columbia is. So while it may look quite north, it's still, just below the 49th parallel? All right, so this is one of the first images from the Viking landers, or orbiters at this point. I chose this image mainly so you can see the atmosphere, and I'm actually really glad that it shows up. So you do see a bunch of haze and potentially clouds right here. So this was one of our first, or not the first, but it was one of our first understandings that Mars has an atmosphere and that there's stuff in it. We have seen that before with telescopic observations, but this was direct confirmation from an orbiting satellite. So some more firsts. The first image is the first image taken on the surface of another planet. This is pretty much when something lands, they like to take an image of their feet so they know that they landed properly, or if there's anything out of the normal that they need to know about. So landed successfully. And then this one is another image. I chose it. The features are very faint, but if you can kind of tell like a gradient coming right here. And when I first saw this, I thought, oh, that's haze in the sky, and we can see something. But that's actually just an artifact of the image itself. But the cloud is this long horizontal streak right here. So this is one of the first observations of clouds on another planet from the surface of said planet.
Question.
Yeah.
What material is the cloud?
So they are predominantly carbon dioxide ice or water ice. It depends on where you are. Since this is really north, I would assume it was carbon dioxide ice. So one thing that I will be repeating for most of the missions that we look at is that we like to look at the sun when we're on Mars. And so the very top photo is actually a color image of looking at the sun from one of the Viking lander sites. And so you kind of notice there's a giant blob here, so it's probably oversaturated there. But around it, you can kind of see some color, and that color is blue. So a really interesting effect that happens in the Martian atmosphere is that when the sun sets, sunsets are blue on Mars. When the sun is directly overhead, it's more of a reddish color in the sky. But due to the forward scattering nature of these particles, they like to scatter blue more forward, and so you see blue sunsets. And then the next image. So it's really hard to tell in this black and white photo. I tried to get a nice color image for you. However, every color image I can find was not in public domain, and so I did not want to have to purchase it. So someone just artificially colored this image, but you can kind of tell that the colors are a little different. So we see a lot of white, and then we see a darker gray, and then some white and some gray. So this is one of the first images of frost on Mars. And so this is probably, I believe, carbon dioxide ice or frost. All right, so from the Viking mission, what did we learn? So this gave us our most complete view of Mars to date. So this was back in 1977. I was very naive in thinking that we should have known all of this already by then, but I did not live through this era. So I did not know that there was a time before we knew that Mars had volcanoes, lava plains, immersive canyons. So it has wind-formed features, which is something really interesting, and I'll be discussing those later. That's one of the characteristics of Mars that I'm really interested in. Evidence of surface water is present, at least from the orbiters. So these are river deltas. So Mars is divisible into two regions, the northern region and the southern region. In the south, the land is generally a lot higher than the land in the north. So the surface material is iron-rich clay, at least at the two places where these two orbiters landed. Measured temperatures range between negative 120 to negative 20 degrees Celsius. So still really cold, with a 35 to 50 degree swing during the day, which is incredible. And we had already known about seasonal dust storms and pressure changes, but these were actually verified by the rovers and the landers and orbiters. There was also a biology experiment on it that produced no evidence of life at either landing site. All right, so now we're jumping up 20 years to Mars Pathfinder. And so all of the stuff that we had at Mars between 1977 and 1997 were mainly orbiters. And then the Viking 1 mission lasted for a very long time until the early 80s. So we just didn't really go in the 80s or early 90s. So this is another lander system. However, it also has a little rover. So this is Sojourner. Unlike the Viking mission, they did not orbit the planet to find a landing site. The landing site was already chosen before it left Earth. And I don't have a size comparison for this one, sorry. All right, so Pathfinder is here. Again, I don't remember the name of the landing site. I feel horrible for this. But it is roughly around Baja California, if you compare it to Earth. So again, Sojourner. This was the first image taken after Sojourner had left the landing lander. Its little case on the lander. And again, imaging the sun from Mars because we like to do that. So we do this for a variety of reasons, not just to get beautiful sunsets, though sometimes it is just for beautiful sunsets. We image the sun so we can figure out the number of particles of dust and ice within the air. So if you look at different wavelengths, you can determine what is dust and what is CO2 ice or water ice crystals. But this one was probably just to get a beautiful picture of the sun setting. So I was afraid this one would not show up. So with Mars Pathfinder, it was one of the first direct observations of dust lifting events from the surface of Mars. And so some brilliant scientists saw this image and said, there is a dust devil in this image. I don't see it. Even on my computer screen, I don't see it. But they enhanced the image, so just adjusting the colors and the brightnesses. And we actually do see quite a large feature right here. I hope you can see it. I can barely make it out right now. So this was potentially, or the first detection of dust devils on Mars, not from orbit and not from telescopic evidence. So some of the big climate things that we learned from Pathfinder were that the sizes of these airborne particles are roughly 1 micrometer in radius. So this is really tiny. This is actually roughly the same size as cigarette smoke. So it's very fine, and I would imagine you don't want this stuff in your lungs. It also discovered that there is a magnetic nature to the Martian soil. And I put soil in quotes here because according to one of my astrobiologist friends, soil is dirt with live stuff in it. So another word that we use is called regolith, but I believe I've used soil in quotes for this whole thing. And also the color of the soils suggested that Mars was potentially in a warmer and wetter environment in the past. And this is something that is still up for debate as to how long it was wet and how wet it was, but we do believe and we do know that there is strong evidence for water in Mars's past. All right, so again, in the same spirit as the Viking missions, NASA decided to send 2 rovers this time to Mars, Spirit and Opportunity. This was back in 2004, and one of them is still running. This is Opportunity is still running. It's still giving us data. I use some of its data, and it's been going on for some 4,800 Earth days. So it's really amazing. It has solar panels, and Spirit unfortunately died once its batteries depleted because there was too much dust on its solar panels, battery drained, and it just wouldn't recharge even when dust cleared the solar panels. The reason Opportunity is still existing is because of the solar energy or the solar panels. So they do get dirty, but every now and then a giant gust of wind comes by and takes all of the dust off, and it's able to survive. So Opportunity is pretty equatorial, and Spirit is just south of the equator. I believe it's at -14 degrees, it's at 14 degrees south. Spirit, I believe, is at Gusev crater, and Opportunity is at yeah, I can't pronounce it, sorry. Mars has some interesting named places, such as Mars Dallas and others. So these badges actually remind me of my childhood. So this is Marvin the Martian, and that is one of the ducks, Daffy or Donald, I'm not sure which. So engineers do have a sense of humor. All right, so again, we have evidence of a dust devil event. So you can actually make it out in the raw image here. And then this is another image that I wanted to show, just to show kind of contrast. So a lot of times when we take color imagery on Mars, it's for the geologists. And the geologists want to know what something would look like under Earth conditions. So they do something weird with the sky balancing, or with the white balancing. So in this image, it's a color image, but the sky is completely white. And so that's something that you kind of expect to see on Earth. And so what this does is it's just the raw, unprocessed image. You're looking at Mars as Mars would look to you if you were on the surface of it. So this one is enhanced, and then this one is the raw. So we see the surface of Mars up until the horizon, and then from here on up is Martian sky. All right, so I showed you a picture of a dust devil. However, Opportunity, yes, that's the one that's still alive, is very good at viewing, Spirit is really good at picking up dust devil events. So what you can do is you just point the camera in the right direction at the right time of day during the right season, and you can get dust devils like this. So I can see 2, 3, 4, 5, 6, 7, maybe? So this was, Mark Lemon, I worked with him. He's an amazing guy. He's down at Texas A&M. He hosts a website that has every single one of these images, or every single one of these movies processed and online for everyone to look at. And he has a little rating system, and this one was 5 exclamation points. So it's one of the best examples. All right, so this is also where I want to discuss the dust in the sky. So this image is probably not the best image, but it does explain what I wanted to get across. So Mars experiences global dust storms, and these global dust storms essentially block out the sun. So at the top is the tau value. So tau is just the optical depth of the atmosphere, and it started at roughly 1. So this means that 10 to the negative 1% of the sun's light is hitting you. So if you were to expect all of the sun's light to hit you if you're at the very top of the atmosphere, this means that you're getting 10% at the bottom of the atmosphere. And so as this storm continues, so right here you see the day numbers, and it's very low resolution, but I believe this one is 1280, and this is 1333. So over the course of 50 days or so, the tau value goes from 1 to nearly 5. So that's a huge reduction in the amount of light that you are receiving if you were on the surface of Mars. And so this was probably not good for the rover, considering it had solar panels, but it also has batteries, so hopefully it had a nice charge before the dust came in. All right, so again, from Mark Lemon at Texas A&M. So as I had mentioned before, one of these rovers is still running, and it's still collecting data. And so this graph shows all of the data that it's ever collected to determine how much dust is in the atmosphere above the rover. So the value that I showed you at the top of the last image is the tau value, so that's listed here. And then on this axis, it's the season. So you can kind of think of it as every 90 steps is a different season. So 0 would be fall, 90 to 180 would be winter, 180 to 270 would be spring, and then 270 to 360 would be summer. So we see that it's very repeatable year after year. So all of the different colors are for different years. You see this downward slope right here, and then every now and then we'll see spikes. So these are just smaller dust events, meaning dust storms. So they can be regional, local, or global. And then you see quite a few of them just go off this graph. So these are the big global dust storms that last for a very long time. He doesn't include their peaks on here just because it would make this essentially look like a flat line, and that's not good. So yeah, I grabbed this morning. So Wednesday, May 10th, 2017 at 16:15 UTC. And he updates this every day. So we always know what the opacity is, at least at this location. All right, so now we're jumping up another decade. Or actually, no, I guess this is only just 4 years. So this is to Phoenix landed. This lasted 161 days on Mars, which is still a mission success because it was only, the success would have been for 90 days, and we met that. So that's good. So this is a 360-degree panorama from its point of view. So again, we have solar panels, and we have a few parts sticking up. So one little anecdote, this little guy up here is a little bob hanging from the mast, and there's a mirror on the other side of it. And what this was for was to determine which way the wind was blowing, because at this point they didn't have anything more sophisticated than this, and this was a very cheap mission. And my boss actually was the one who processed all of these images, and he loves to mention that this is the most photographed thing in space. Something around 6,000 images of this little guy were taken, and my boss went through all of them and determined which way the wind was blowing at that instant in time. So Phoenix is all the way up here. This is the most polar location that we've been to on Mars, and after the Phoenix mission, the polar regions are essentially off limits. This is to avoid contamination because we now believe that there is water there, and we don't want to bring any Earth species to Mars and have an explosion of life. So again, it's so north that it is in, if it were on Earth, it would be in Nunavik, northwestern territories. So only 2 sites that we visited are within Canada's borders. So from that main picture, you can kind of make out the Canada logo here with the Canadian flag. So Canada had a huge involvement with this mission. They designed the meteorological station, or MET for short. So James Whiteway, he was the lead for the Canadian science team. He is one of my other advisors at York. And Mike Daly, he was the lead for the Canadian engineering team. He was at MDA, and now he's at York, and now he's another one of my advisors. Peter Taylor at York, Alan Carswell at York, Carlos Lange from University of Alberta, David Fisher from Natural Resources Canada, and Thomas Duck from Dalhousie University. And my boss also worked on Phoenix, but he did not work with the Canadian team because he was in Arizona at the time, even though he is Canadian. All right, so I'm going to discuss the meteorological station in a little bit more detail, mainly because it's a huge part of my university, and if I don't know this stuff, I would be banished. So this is the first time we sent a LiDAR system to another planet, so or at least to the surface of a planet. So LiDAR, what it does is it shoots a laser into the sky, and then it has a telescope that then records when the light comes back from it. So right here, you can barely make it out in this image, but we see a nice beam of light right here. So this is from a separate camera, just wanting to make sure that the experiment was working. And so this GIF or animation shows some turbidity in the sky, so we do see stuff. And it records this information for, I believe sometimes it's on for an hour. It just depends on what they were trying to find. And so on this particular day, this is their best example of finding something very interesting on Mars. So fall streaks. So the way that you read this graph is time is on the bottom, and the color is just how much light comes back to you. So if it's red, a lot of light came back to us, and this is the altitude. So right here, we see that a lot of light started coming back to us around 375 or 3.75 kilometers. So this also gives us like the thickness of whatever it is that we're looking at. And so it was determined that these were clouds. And as time went on, we started to see some fall streaks. So fall streaks is just another word for snowing. Though it likely did not reach it all the way to the ground. But this is the first evidence of snow on another planet. There's a few other examples, and we do compare these to what we see with clouds on Earth, and you can see the same types of things. So another thing near and dear to my research group's heart are clouds. So this is a little animation that shows cloud movement. So this is again at Phoenix, and these are extremely gorgeous clouds. We're trying to find clouds like this with Mars Science Laboratory, but we don't see anything quite as beautiful as these. And then this image is kind of deceiving. So it's the detection of frost. So there's a little arm on Phoenix, and what it did is it scooped the ground, and it saw this. So this is carbon dioxide frost, and I thought that was the point of this photo, was to show this. But then you notice that they're showing this picture, so they're separated by 4 days. These guys look the same to me. And then you notice the inset. So that's from right here. So we see 4 little things that are white in this image, and then completely absent here. So this is showing frost becoming not frost. So frost sublimating. All right, so just one last thing about Phoenix. So since we have several of the key scientists and engineers still at York University, there's still a lot of research going into the LiDAR instruments and just understanding all of the data that's coming back. And in one of the labs, they're using the temperature data from this lander to try and see if it was possible for there to be liquids at the Phoenix site, and they just didn't see it. So the reason why they want to see it is because they would generally happen at nighttime. So it's not liquid water that you can have, but if you have very salty brines, you can potentially form liquids on the surface of Mars at those proper temperatures and pressures. So those are really interesting studies, and liquid does exist. So that we already kind of knew that it existed in the past, but this is a potential step forward to understanding how water and brines are on the surface of Mars today. All right, so now to something that I know a little bit more about. So this is Mars Science Laboratory. We don't have a human for scale here, but I've been told several times that it's roughly the size of a Mini Cooper. It's landed at Gale Crater. So if you notice, it's not in yellow like all the others, because this map was the map of potential landing sites for Mars Science Laboratory, and the scientists decided to land it at Gale Crater. It's roughly 5 degrees south, or 6 degrees south. So the Mars Science Laboratory has a full-fledged weather station on it. It's called the Rover Environmental Monitoring Station, and you can get air temperature, ground temperature. So these are 2 sensors. One of them is just up in the air and gives you the air temperature, and another one is a sensor that's aimed at the ground and gives you a ground temperature. You can get wind speed and direction, at least that was what they wanted to do in theory, but when we landed, something broke. So you can really only get speed and direction if the rover's pointed in proper way. It can tell you how much UV radiation you're getting from the sun at any given point. Let's see what else. Oh, relative humidity and pressure. And every day or so, they update. They have a little weather app online / on your phone. I tried to download it for my phone, but it no longer works. But they do update the website daily. So on this particular day, I believe that's the air temperature had a maximum of -13 degrees Celsius and a minimum temperature of -76. And they update things as much as they can. Oh, and 1 year ago tomorrow, Mars celebrated its 2 years, or the Mars Science Laboratory celebrated its first 2 Martian years on Mars. And so to mark that occasion, the environmental science team that I'm a part of decided to put together a press release detailing all of the weather stuff that we have seen at Gale Crater. All right, so since the Mars Science Laboratory is based out of Pasadena, they're showing the beautiful weather in Los Angeles, California, and comparing it to the beautiful weather at Gale Crater. So we can pretty much just call it 20 degrees in Los Angeles. But for Mars, it is a huge range. So kind of follows a sinusoid, except we see a little dip here. But that's explained by the kind of double effect of winter that it can have. So it also has a double effect of summer. So this map, or this graph, doesn't necessarily do it justice. These are the average temperatures for each month or 30 days. I don't really know how they average these. But the maximum temperature seen with MSL so far is 16 degrees Celsius, and the minimum temperature is roughly -100 degrees Celsius. So quite chilly, though at times kind of warm. I believe that was warmer than it was today. But it doesn't stay that warm for that long, and again, you can potentially experience a 50-degree drop by nighttime. All right, so water content. Mars is very, very dry in the atmosphere. It's pretty much a desert, except on cold winter nights, relative humidity is very high, even though it has relatively low water. So the red is the water. So the red is the water. They measure this in parts per million. Gale averages around 40 parts per million, whereas if you just go anywhere on the Earth, you're looking at 20,000 parts per million. So there's quite a big difference between Earth and Mars with that respect. Atmospheric pressure, so it differs depending on what season you're in. So depending on the winter, it's very cold, and so the atmosphere condenses and it's less pressure. And then in the summer, yes, it expands. So the atmosphere, again, I said earlier, it's roughly 100 times lower than what it is on Earth. So it's not quite a near vacuum, but for a human, you would feel like you were in a vacuum. All right, so my work was actually summarized in this press release. The press release was roughly 1,000 words long, and I got a beautiful 24 words. So the visibility in Gale Crater is as low as 20 miles, or 30 kilometers, in summer, and as high as 80 miles, or 130 kilometers in winter. So what I do is I look at how much dust is in the atmosphere, but instead of like other studies where they look at the sun or they look up, I'm looking straight out from the rover. And there's this beautiful feature that I'll show you in a bit that we're looking at. And what I do is I determine how much dust there is there. And once I have that number, I can back out how far you would be able to see if there was nothing in your way. And we got roughly 40 kilometers in the summer, or sorry, roughly 30 kilometers in the summers, and up to 130 kilometers in winter. So we kind of correlated this with haze that you would see on Earth. So LA has a lot of pollution, so their visibility is very low sometimes. But on Mars, you can see for a very far distance if you have a straight line of sight. All right, so this is the sciencey part. So what I do is I look at images like this. So this is the crater rim. That's roughly 25 to 30 kilometers away from the rover at any given point. And I look at 3 different sections of the crater rim, or sorry, of the image, to pretty much just tease out how much dust is there. And so the little cartoon diagram that we do is we say, if you're looking at the sun, if you're looking at the sky, you're looking at nothing but dust. If you're looking at the crater rim, you're looking at the crater rim plus the dust between the rover and the crater rim. And then if you look at the ground, you should be seeing nothing but the ground color. And then we throw it into this little handy-dandy equation, and we get out our numbers of how much dust is between the rover and this black bar going across. All right, so here's some GIFs. So this one is every single image that I've looked at. It spans, I believe this one spans 1,500 days on Mars. And so if you pay attention, you can see that the crater rim is shrinking as it goes along. This is because the rover is moving away from the crater rim. And then over here, this was taken over a series of maybe 50 days on Mars. And it's just a high resolution color image showing that the dust loading does change almost enough so that the crater rim is completely blocked when it was completely visible before. So again, with the sun's setting, so this time there's a sunset movie. There's a few other movies that I couldn't really find. We have transit movies of one of the moons going over. But again, we notice, so this is a color image, and we notice that we have this blue halo emitting from the sun. So for a very long time, we could not find dust devils at Gale Crater. This was supposed to be my original thesis work, was looking at dust devils at Gale Crater. However, we didn't start seeing them until about 3 months ago. The reason, we were looking in the wrong direction. So before I joined the mission, there was a bunch of surveys. They looked all around the rover, trying to find them. They didn't find any. And so we're like, okay, let's just look north. We have a good line of sight to the crater rim. We should be able to see some of these events. And so several hundreds of days go by on Mars, and we still don't see anything, and we've kind of given up hope. However, one of the camera people noticed something weird with one of the images. Completely random, it was just an image of something for a geologist, but they brought it up to the environmental science team, and we noticed that between 2 images there was a uplift of dust. And this would happen to be towards the south. And so we started to look to the south again, and we've seen all kinds of dust devils. So again, this is from Texas A&M, so that Mark Lemon person I was talking about earlier, who hosts the dust devil movies for the other missions. He now hosts these as well. So yes, when the rover landed and it looked around everywhere, we were just not in the right season. So had we continued looking all around the rover, eventually we would start seeing them again in the south. It was just a very unfortunate series of events that led us to be looking in the wrong direction for a very long time. All right, so as I mentioned earlier, near and dear to my group's heart are cloud movies. So unfortunately, unlike at Phoenix, where you can visually see them in the unprocessed images, you can't quite do that here. So this is one of the best examples that we have where you can see it in an unprocessed image, though I don't necessarily know if you guys can see it. But if you look right here, you can see some cloud belts moving towards the rover. So a lot of the clouds that we see at Curiosity are suboptical. So this means that you can pretty much not even tell that they're there unless you're doing some magic with some software. And so we like to perform magic What we do is we stack all of these images together and we create a mean frame, and then we subtract it out from every single image, and you get something that is very grainy, but it displays features that are different in each of the different frames. So most of our images that we look at, or most of our movies that we look at, come back like this. However, every now and then you kind of make it out. So this is one of the first images or movies of gravity waves on another planet. So these are clouds that are formed by going over the mountain range, and they kind of do like a sinusoidal thing. I don't have any examples of Earth, but we do see them on Earth, and they're kind of cool. All right, so some more clouds. So this one is looking straight up from the rover, and you can see clouds generally moving in this direction. And this is one of my movies, actually. So I was looking for the dust devils in the wrong direction. However, as environmentalists, we generally just look at the sky. So when we told the rover to take this image for us, we had no idea this giant dune was in our way. So when they came back, they're like, oh, hey, by the way, that dune is in the way, so you can't really see anything, so you're not going to find dust devils with these. But we process them anyway, and we see cloud movement. So it's a win-win. So a nice, huge dune with some clouds above it. All right, so speaking of dunes, so these are, Curiosity is visiting is the first rover to visit an active dune field on another planet. So this is that same dune that I had just shown you before. And what we didn't know until we got there was whether or not these were active or if they were non-active. And so we see all of these features that look like they were developed by wind, but we don't know if that is still going on right now. We have very good evidence that it is still going on, mainly from this series of images that were taken a day apart from each other. We see the sand shifting. So wind comes in, blows the sand, and you get different little ripples in the ground. All right, so that's all of it for the landed assets. So I just wanted to take a little moment to discuss other observations. So I left out nearly every single orbiter that has been to Mars, and telescopic observations. So these are from a flyby by Mariner 4 in 1965. These were the first images taken of Mars from a close distance to Mars. This is the unprocessed image, and you can kind of make out a haze in the atmosphere. But if you were just to show this to me, I would have no idea what I was looking at. And then this is another image showing several craters, and I really wish there were a scale bar on here. So that, again, that was in the mid-60s. So the Hubble Space Telescope actually takes beautiful images of Mars. So I wanted to show this to demonstrate what a global dust storm looks like. So here you can see craters, and you can see the polar caps, and here you can see absolutely nothing. So this is an entire global dust storm that encircled Mars. And we see that every now and then. The big global dust storms happen not every year, maybe once a decade or so. So here are some other images from the Hubble Space Telescope. So I chose this one because it shows clouds, which are near and dear to my heart. And these are actually very interesting because I didn't think you could actually get images like this with Hubble of Mars's north and south poles. Or sorry, I guess in this case just the north polar cap. So what I failed to remember is that Mars rotates. So as Mars rotates, you can observe all different parts of its northern polar cap. And so we have maps of Mars's north pole by looking at it from Earth. All right, so a little bit more about orbiters. So again, this is the picture from one of the Viking orbiters. Actually, they both are. And this one actually shows a series of canyons with clouds in them. So I thought that was really interesting. So clouds do form. And now into the 2000s or so, technology has improved a lot. This is not the highest resolution that we can get of these images. So this is from the Mars Reconnaissance Orbiter, specifically the HiRISE camera. So it is a very high resolution push broom camera that can roughly measure, it can take images at about 25 centimeters per pixel. So if you have something that is 1 meter long, you can get 4 pixels of it on these images. So with this camera, you can actually see the rovers and landers that we've sent to Mars on the surface of Mars from orbit. It does other things as well. So you can also get the elevation of items or of geological features. So right here, this is a crater. It was potentially one of the landing sites for one of the assets that we sent to Mars. And you see at the bottom of the crater, it's roughly 1.4 kilometers below sea level, which in this case is just a random number that the scientists chose. Whereas higher parts are about 1.3 kilometers below sea level. Another part of that, the Mars Reconnaissance Orbiter, is a color imager called MARCI, and every week it gives you an updated status on the weather at Mars. So this is an orbiter. It orbits Mars in a polar orbit, and it maps the entire planet roughly every single day. And this is the caption for this week. So happy Martian New Year. So Mars just celebrated its New Year, which just means that it's starting its year again, and I believe it's Mars year 34. Last week on Mars, winter became spring and summer turned into autumn in the northern and southern hemispheres respectively. Looking along the seasonal north polar caps. Short-lived dust storms and water ice clouds continue to propagate eastward and continue to dip over Acidelta and Utopia. So yeah, you get a full weather report every week, and generally at the bottom, it tells us about the 2 landed assets that we have on Mars right now. So Curiosity and Gale and Opportunity on Meridiani Planum experience storm-free conditions on every single sol. So a sol is just a Martian day. So again, these are hosted and publicly available to you. So if you ever want to see what Mars looks like on a particular day, you can go and check out Mars. So some other orbiters. So there's more to orbiters than just getting pretty images. So you can check out, or you can learn about the atmosphere and the composition of the surface. So since I'm an atmospheric scientist, I'm more interested in the atmosphere stuff. So with TESS, which is on the Mars Global Surveyor, it is a thermal emission spectrograph. What you can do is you can get how much dust is in the air all over the planet on every single day of every single year. You can also get temperatures, water ice abundances, and water vapor in the column. And then this one is from the same instrument. It's just a little GIF showing how temperature changes over a series of days. So at the top, we're roughly negative 125 Celsius, and then towards the red, it gets closer to negative 65 degrees Celsius. So still very, very cold. One of the newer assets at Mars is called the Mars Atmosphere and Volatile Evolution. So this is called MAVEN for short, and it has an imaging ultraviolet spectrograph on it. So what this does is it looks at Mars, and it's able to tell what different types of elements are seen in the atmosphere around Mars. So these were some of the first images that it sent back to us. So right here is where Mars would be, and the blue represents hydrogen escaping from the Martian atmosphere. We see oxygen closer to the planet. This is because oxygen is heavier Though there is a very small amount of oxygen in Martian atmosphere, you can still detect it. This is reflected sunlight, and this is just a composite of all three of those colors, giving a almost false color image for Mars. All right, so my talk has been exclusively NASA did this, NASA did that. However, ESA has been to Mars several times, and the former Soviet Union has sent a few things. So researching this, I discovered that nearly half of everything that we've sent to Mars has failed in some way, shape, or form, though we have been getting a lot better at it recently. Though the last thing to go to Mars crashed. So that was ESA and Russia's Schiaparelli lander. However, recently, India went to Mars. So this was an extremely cheap mission, but they are still doing extremely good science with it. So this is Valles Marineris, if I remember correctly, and you see clouds within the valley. And what they did is they determined how much clouds were in this valley. And then this is just a full Mars view. And there's several other countries that have ambitions to go to Mars. So China, they've attempted a few times, but they're going to attempt again. JAXA, which is Japan's space agency, has something in the works, I believe. And the United Arab Emirates is planning on going soon. And India is going to send their second orbiter within the next few years as well. All right, so in summary, without protection, a summer's day on Mars is probably worse than any winter in Canada. But obviously, we won't send people there without protection. That would just be rude. And I'm going to end with one of my favorite images. So as I had shown before, I look at the crater rim, and this is a outline of a crater. Sorry, the outline is something I'm very familiar with. Though I always do love the high resolution images with the blue sky, even though that's not quite accurate. But yeah, that's my talk, and any questions?
CO2 ice, perhaps water ice. Is there any regions where there's you get liquid?
So yes, there are some things. They are called reoccurring slope lineae, RSLs for short. We do see them on Mars through orbital through photographs from orbit, and even the Mars Science Laboratory has photographed these from a distance. So what these are is you're looking at a slope, and between images you notice something like a snake coming down. So we've never actually caught it in action, but the only thing that we can think of that would produce this is liquid something. So we do think it's water, but it's not confirmed. There is a mandate that we cannot go there with Curiosity and touch it and investigate it further, so we can only do this with remote sensing. And they're maybe 20 kilometers away from the rover, so we're relying on imagery for these. So the reason we can't go there is because Curiosity wasn't cleaned as well as we had hoped it would be. And again, if there's water there, we don't want to contaminate anything. Yep.
Other than it sounds like the skiing would really suck there.
Yes.
Why would you mentioned that the polar caps are off limits because of contamination with microbes, but with such a wind current on the planet, would that matter? I mean, the minute that we touched down and there was any minute amount of microbe, couldn't it potentially contaminate the whole planet?
Yeah, so it's just being extra precautious. So Curiosity was sterilized, even though it was going to an equatorial region. A lot of times people or agencies just don't want to spend the extra money to get the extra certification that they were properly sterilized. And I mean, there are studies to test the habitability of Earth organisms on Mars. So there's a combination of effects that would kill them, but you just want to be careful and make sure nothing's hiding. So what I've seen is that even on the underside of the spacecraft, if you forgot to get something, it could just lay dormant there until it magically heats up and has access to water, and you just don't want to bring life to another planet, at least at this point. Yeah.
Why is the blue portion of the electromagnetic spectrum prevailing during sunsets? It doesn't appear on Earth, of course, for obvious reasons.
Yeah.
Why there?
Okay, so it's the dust particles that cause that. And so what happens essentially is that the blue part of the electromagnetic spectrum favors going straight towards you, whereas the red goes outwards.
Yeah.
And so if you actually were to have a sunset with the sun over here, and you were looking all the way across 180 degrees in the sky, you would see it gets redder and redder and redder as you go away from the sun. So it's just the blue favors going straight towards you, and the red favors going off to the sides. Yeah.
Just kind of two related questions. One is, on Earth there's pretty organized air circulation systems,
Yes.
highs and lows. Is it the same on Mars? And the related one, I guess, is what drives a global dust storm on Mars?
Okay. So there are circulation models that exist. So we have a good idea of what is circulating on Mars. Whether or not there are predictable patterns is yet to be known. But to answer your question, it's kind of a complex feedback mechanism. So the more dust you have in the atmosphere, the warmer the Martian atmosphere gets. And the warmer it gets, the more windy it gets. And so the more dust gets lofted into the atmosphere. So as soon as you get a regional local dust storm, it has the potential to develop into a regional dust storm, which then has the potential to develop into a global dust storm, just depending on the heating, so what season you're in, and how much of that feedback is going back into the system.
Why would the dust devils only form sort of in one direction? Like if you're in the crater, are they not sort of sweeping way across it?
So Gale Crater is massive. It's 140 kilometers in diameter, and we were looking to the north. And Gale is located on that boundary where we have the southern highlands and the northern lowlands. And when we're looking north, the northern part of the crater is lower than the southern part of the crater. And what happens is there's kind of just like a jumping effect of the winds coming from the south. So the air within the crater is kind of not really affected by the air inside of the crater. However, as we look south, Curiosity is driving up a mountain. And so we're getting higher and higher up into the atmosphere, and we just think that there's more interactions between the atmosphere above the crater and the atmosphere in the crater as we're getting higher and higher up in elevation. So it's likely just that we're looking too low when we're looking north, we're looking too low in the atmosphere. But when we look south, we're actually looking higher in elevation.
So then what elevation are, let's say, cloud tops if they there? How far up?
So we are trying to figure that out by looking at those cloud movies and using some modeling, the winds. But we're assuming that they're roughly between 20 and 30 kilometers higher than the crater floor. Okay.
When the volcanism actually occurred on Mars and when it stopped? Any way of determining that?
There are ways to determine it. I believe it has stopped. I believe there's only a few volcanically active systems in our solar system. Mars is not one of them. I don't know anything about geology, but I do know that people have studied it. We have not necessarily studied it, but through thermal mapping, we can tell that it's not any warmer under this volcano, so it's likely not active. as well. Yes.
Just one question. How did those initial orbiters decide to choose where they landed on Mars, and why are we focusing on areas that the rovers are on now?
Okay. So with Viking mission, they sent the rover, or not rover, the lander and orbiter, all in one piece. And what it did is it orbited Mars for roughly a month, and it sent back images. And the scientists of that era looked at these images and decided what they thought would be most interesting to study. So each mission has its own guidelines, and for Viking, one of them was to see if they could potentially find life. Because before then, the highest resolution images that we had was about 1 kilometer per pixel, and you can't tell if life exists at 1 kilometer per pixel. And so they chose their locations based off of probably seeing those water veins or river deltas, and just wanted to explore those a little bit more. And then why are the other places, or sorry, why are the other missions where they are now? It's again NASA has a priority to try and find water, and so they're looking at the most probable places that they can find water that are also of interest to geologists. The environmentalists don't really care where we go. But with Gale Crater, we now know that it was likely a lake at one point. So we have succeeded at least in finding water. It's not present in the current era, but it was before. Yeah.
The atmosphere in Mars is so thin compared to us. What is it, 1/20th?
1/100th.
1/100th. I'm surprised the winds there could raise any dust, and I'm not sure whether it's that the winds there are higher speeds or the particles are smaller because of some process on Mars,
Yes.
or maybe the absence of life to hold things in place. I'm just astounded that the dust could blow.
Yes, so it is a combination of those two effects. So it is a thinner atmosphere, but the particles are a lot smaller, and the heating differences are different. They were saying, or we have seen roughly 30 to 50 degree changes in one day, and so that would create a very fast-moving wind. I don't have any of the measurements in this slide or in this presentation, but I have seen things saying that the wind can get up to 56 kilometers an hour, which I think I've experienced faster than that on Earth. But these are very fine particles, so it's probably just very easy to lift them. However, if you watched The Martian, I don't think the winds would be strong enough to push Matt Damon away.
On that, how accurate is the book/movie?
I had no qualms with it. My advisor chuckled at it a lot. I didn't read it for science, I read it for entertainment, so I can't really comment, sorry.
Based on scaling, how big are these dust devils?
So they're quite large. You can actually see them from orbital observations. I believe.
Would it equate to tornadoes here on Earth?
Probably not, no. So dust devils, so not tornado size. I don't know if you've ever been to the desert and seen dust devils. I would say at times they can get up to maybe 500 meters in height, maybe more, but they're not a strong source like a tornado would be. Yeah.
No, I was just gesturing.
Do we have any questions on?
That was back here between us, and I just asked my friend if he'd ever seen a snow devil.
Oh.
And I have, so same sort of thing, small dry particles, very cold day with good wind. Similar, I guess.
It's a very good presentation.
Thank you very much.
Any more questions?
Well, as you can see, you prompted a lot of really good questions.
Yes.
So on behalf of everybody here and everybody who's online, like to present you with a little RASC calendar.
Thank you.
With some very good examples of Canadian astrophotography.
Nice.
So something to decorate your office wall other
Yes.
than Martian images, and also a small tool.
Okay. All right.
So thank you so
Thank
much.
you.
Okay, to finish off, I'm just going to run through the announcements very quickly to just talk about some future events. So let's go with the next meeting, which will be in 2 weeks' time, and that's our Recreation and Astronomy Night. So on that evening, for the folks who are new here, what that will involve is 3 short presentations. One is the Sky This Month, which will be looking at events over the next 4 weeks or so, in that starting from May 24th. And then we have 2 talks. Alex Stemnier talking about travel to Alpha Centauri, and Brian Charnick, who will be talking about space for sale, collecting meteorites. And those are just short talks. Okay, observing programs. Our next solar observing program is on the weekend to replace the cloud out last weekend. And that will be from 10 o'clock until noon on the telescape out on the front of the Science Center. And Sean, who is our coordinator for solar observing, will do a go or no-go call on that online using the Yahoo list, as well as our website and Twitter. So all of those watch for either Friday night or first thing Saturday morning for the go or no-go call. Also, our monthly evening Star Party events. We have the Dark Sky Star Party, which will be on the first clear night between the 29th of May and the 1st of June at Long Sault Conservation Area. And the City Star Parties, the next ones are scheduled for the first clear night the last week of June, 26th to the 29th at Bayview Village Park. And again, watch for the go or no-go calls. There is an outreach program coming up very soon on Friday, 19th of May at Millennium Square in Pickering. And that'll be what's set up starting about 6 p.m. that evening. And the public program will go through until 11 o'clock. And again, we will be putting an announcement of go or no-go onto the website and probably on Twitter as well. And again, you can just turn up if you're interested in helping out with that out in the Durham region. Our dark sky site, the Carr Astronomical Observatory near Thornbury, the road is now open, and you can now start booking time up there using the online reservation form. In preparation for the summer season, we do have a work party that is being organized for the 27th and 28th of this month. And you need to go onto the website after you've logged in with your RASC ID and password to book space. And essentially, because of the space and considerations, the CAO committee is asking that only the first 20 registrants will be accepted for going up there for this work party. You can get information about what is being planned by emailing cao@rascto.ca, and they'll get back to you with the information. Okay, the other thing is that that's all leading up to our annual open house and awards picnic on the 24th of June. So I know it's a little bit early to announce that, but again, this is sort of the standard recipe of what we do on those events. So please plan to come up there to enjoy the site. The dark sky hopefully will be clear, and all the other aspects of the program. And there will be more information about that in scope on the website. Some of you will recall that there was some talk back in the winter about the expression of interest for presenting public education programs at the David Dunlap Observatory. The Toronto Centre did file an expression of interest with the town of Richmond Hill on the 28th of February. We were invited to meet with Richmond Hill staff and do a formal presentation, and that occurred on May the 2nd. And so now what we're doing is just waiting for the town to make its decision as to who is going to be asked to actually do public education programs on the site. And it's going to be a little while before we know exactly what is going to happen there. Among other things, the town has indicated that they intend to train their own staff to actually maintain the property and run the telescope. They also intend to have any groups that go in there using the facility on a non-exclusive basis. That's all we know at this point. They did suggest that they will allow us to apply for permits so that we can do some outreach on the lawn during the summer before any decision is made about actually using the interior of the building. So that means that there's a possibility that we might be able to do something during the summer, but again, we haven't got anything definitive from them, and if there is anything that develops, we will put it onto the website and probably do an email blast by MailChimp to let you know what is going on in that respect. But right now, everything's still very much up in the air. So just be patient, we'll see what happens. But it is somewhat optimistic that there is going to be something happening later on in the year in terms of actual education events at the observatory.
Ralph, that's just a quick question.
Yeah.
So I used to live right next door there. Mm-hmm. Is the telescope currently in use, or is the thing in mothball right now?
The telescope is being, as they called, exercised. One of the former observatory staff from the university has been hired to move the telescope around. So, if you're up there, you might hear the dome moving and things because the machinery does have to be run every once in a while. That person's also been given a contract to instruct the Richmond Hill Park staff on how to operate the facility, and presumably he's also teaching them how to run the telescope as well as some of the aspects of maintenance. But again, we have nothing in the way of direct information about what is going on in that respect. So what I've got is what was reported to me from our delegation who went to meet with the Richmond Hill folks last week.
Thanks, Rob.
Okay, so bit by bit things are coming together, and we'll just have to wait to see what the town actually decides to do. Okay, things that I'd like to remind you about also, other benefits of your membership. Telescope loan program, we do have a lot of equipment that is available. We have all three managers of the loan program here sitting in the middle of the room tonight. So if you are interested in borrowing equipment, see one of these three gentlemen and they will be happy to set you up with any of these things. And it's a first come, first serve, right? Indeed. Okay. And again, the idea is try it before you buy it. So we've got a wide range of equipment, including a full astro imaging package. You can borrow it, see if it works for you before you go out and slap your own money down and buy your own equipment. So definitely a good advantage. I wish we'd had that when I was starting. Anyway, that's it, other than for the meeting up at the Granite Brewery. Again, anybody who wants to go there, you're welcome to join us there. For a few of us, that's the dinner call, so watch for us. We do have a table reserved at the Granite for this evening. So that's it for now. Thank you for coming out tonight, and we'll see you in a couple of weeks' time.